Okay, a better way of building 18650 cells. Watch what happens when I turn the freezer on. So that battery powered that freezer. When you go on YouTube and you start researching and just watching videos on how to make 12-volt batteries from 18650 cells, this is basically one of the most popular configurations that you'd find. So you'd find 3 series and then parallel as much as you want. So your first intuition is to learn how to make this configuration. So what you can see here is that these are actually 3 batteries connected together. So you see these purple ones is 3 series, 1, 2, 3, 4 in parallel, right? And this all from here to here is 1 battery, 3 in series, 1, 2, 3, 4, 5, 6 parallel. This again is 3 series, 1, 2, 3, 4, 5 parallel. So these are batteries that I just built and basically just kept on adding onto it as I got more cells. Of course, you have to match your cells to see that their capacity and their voltage, nominal voltage, match before you combine them really this way. But you can find that the BMS is on this one cell, and I'm basically using this wires to link the batteries together, especially if I want to put things on the horizontal axis. As long as you are, attaching them vertically, just as long as you're attaching them parallel wise, you could just keep on stacking batteries at the back and you keep on, but very soon you'd find that you'd have a space constraint. Like for instance, the box that I wanted to put this battery in could only accommodate, if I stack them, your regular bus bar electrical box, the size that I wanted to put these batteries in could only accommodate this too. And I would run out of space lengthwise. So it was like a cube, which meant that I needed to use the width axis again. So I couldn't basically add one more battery behind this one. Like for instance, I couldn't take this and put it in front and then join together, which meant that I had to utilize the length axis, depending on how you look at it, and then find a way to connect the 2 of them. So you find that right here, I've connected this to this using this wire here, and I've also connected that to that using this wire here. So I basically just remove that. And then if you turn around, let me remove this for safety reasons. If you turn around, you'd also find that something similar has happened. I've connected that to that and there to there. Now this, you find that as you progress with building up this battery, imagine that I wanted to extend it all the way here and then fill up all of this space, you immediately have a problem with all of these wires crisscrossing everywhere. So this is actually an intuitive way of going about it. The moment you learn how to build these battery configurations for 12 volts, ultimately you are getting about 12.6 volts on these 3.7 volts cells when you combine them in 3S series, right? So this was a problem that I faced, and I thought to myself, I said, why do this? Why give myself all of this heartache? I could achieve the same thing simply by building this as one cell, that as one cell, and that as one cell, and then combining those 3 cells in series to get my 12 volts. That way I could still achieve the parallel number of cells that I wanted without having the problem of all of these wires crisscrossing, which is what I'm going to do to this cell right now. So I'm going to remove all of this, really losing out all of these cells, and then build them that way. Like I said, in summary, what I'm going to do is, rather than have this as one 12 volts battery, I'm basically going to just put all of these cells in parallel and have one 3.7 volts nominal cell and use that as my positive. Do the same for this, have all of these cells in parallel and just flip it over and use it as the negative on the upward side, and then do the same for that, and then combine all of them together and have a better battery. So separated them into 3 different batteries. So all I'm going to do is just loosen out all of these nickel strips and have individual cells, and then I'll configure them in the way that I really do plan to do that. So I won't show you the whole process of ripping apart this entire battery pack, but I'll go ahead and do that and I'll get back. So as you can see, I have ripped all of the batteries apart. There are still more. There are still more of them. Just give me a minute, let me pick all of them. I have like a scattered workshop at this point, but really, here are basically all the cells. Because I, cut out all of those nickel strips, I'll have to find a way of getting them out completely. It's a really painful process, ripping apart. I guess that's the only advantage you have for building batteries with soldering wires onto the batteries when you're building, as against using spot welding your batteries. If the wires were soldered on to these batteries, then it would have been easy to just melt out the lead, the solder, and everything would have just been okay. But once you spot weld your batteries, taking them apart is really it's just pain in the wrong places. But I'll get that done and we'll get back to the video. Okay, now that we have all of the batteries ripped off and ripped apart, I guess all of the cells ripped apart, the next thing is to test all the batteries to see that they are working on the one hand and that the voltage is the same across. These ones are, these blue ones, fully charged. Something appears to be wrong with this one. So these are all the batteries that I salvaged. 1, 2, 3, 4, 5, 51, 52, 53, 54. What I'm going to do is to divide 54 by 3. So 54 divided by 3, that will give us 18, meaning that we will have to have 18 cells in parallel connected in series to get 12 volts. If we assume that these are recycled batteries, that each of them is about 1.5 mAh, that will give us a battery capacity of about 18 plus 9. That's 8. This is 7. That's about a 27 Ah battery, which is sizable in the circumstances. So we're going to commence building out this battery now. So let's do it. So these are our first batch of cells. There are 18 of them. 18 divided by 3. So this is the point I was making. So this is one cell. This is 3.7 volts, but in terms of amps capacity, it will be, if each of the cells is estimated to be about 1.5 each, then it will be 1.5 times 1, 2, 3, 4, 5, 6. 3 times 6, 18. So it will be 1.5 times 18, which comes to about 27 Ah. So ultimately, the battery that we're going to build will be about 27 Ah. And you see that we have used our space much more, economically. It's all contained in this little box here. So let's finish out the other cell and then we'll get back to it. So this actually runs to this wire. Just watch. This other wire you see here goes to the chat controller. But as you can see, it's actually night and there's no solar power coming from the charge controller. But check out what's happening. So this wire here goes, this is from the battery. It's applying about 12.2 volts, 12.1 volts, right? This is not showing properly. It's actually reading 12.2, if you can see, yeah, 12.2 right there. So it comes to this battery. But watch what happens. So this is the wire that goes to the freezer. So this is the freezer that I've been using to test my batteries. So this is the freezer. So you can see it's a Boomer DC freezer. It's a 75 watts freezer. But watch what happens when I turn the freezer on. So that battery powered that freezer. And like I said, it is absolute night. No extra watts are coming from the sun or the solar panel. So all of it is practically on the battery, just this battery that I built. And as you can see, the voltage has dropped to about, what's that? Voltage has dropped to about 11.6, which is pretty some juice. Of course, there's load on it, which is why the voltage will drop. But just to prove to you that it's practically dark here, there it is. So you see it is nighttime, and it's powering the fridge. So how long it will power the fridge is a different story altogether. I don't believe it will power it for very long before it actually drains out all of the juice from the battery. But imagine what this can do when you power it with solar panels that is strong enough to carry the freezer, which means you could run your freezer all day while there is sun, and then once it's about 5-6 p.m. you turn it off and use the charge that you have in the battery to run your fans, charge your phones, and just get yourself through the night. So I'm going to put this in a proper casing, pair it to this charge controller. So this is a charge controller that is not in use at the moment. You see that it's just showing. Basically, I'll pair it to this charge controller, fix this inverter to it, and basically use it as my mobile power station for when I'm going camping or, whatever I might want to do. The fridge is still working, the freezer is still working, right? So that's a very capable battery you see right there. Very capable, very capable. I'm proud of it.